Thanks for showing up. I appreciate it. My name is Rob Bennett. I'm a Director of Software Development at Dish Network. I'm joined by Rastogi, who's the Senior Manager of our Middleware Application Development team, and Chandra Nemalipuri, who is the Principal Developer on that team. We're here to talk today a little bit about Dish and what we've been doing in the area of taking our legacy infrastructure and applications and moving them into the cloud-native environment. How many of you are familiar with Dish? Yeah, that's an easy question. So we wore the T-shirt, so you'll see it today. Dish has been around for 30 years. In the mid-90s, we launched a small Dish satellite service that really put us on the map, so to speak. And so we have quite a bit of history. In the early 2000s, actually before I joined Dish, we really made a commitment to service-oriented architecture. So we ended up with a very strong SOA layer of coarse grain services with high reuse, which was, if you've been around as long as I have, that was really what you were going for in the early 2000s with those coarse grain services. These services are built on a legacy platform that we have that mixes Java code with configs in XML, which has the business logic. But recently we set on a path to really transform how we build software, to borrow a phrase from Pivotal. We started working with Pivotal on learning their modified XP practices, adopting test-driven development, pair programming, and the whole 12-factor and microservices type approach to writing software. And as we were doing that, we found we were getting great results, and we wanted to adapt our old SOA platform to this cloud-native format and really take advantage of some specific things such as test-driven development, which we saw a really big benefit in getting quality code out, and continuous integration delivery, which allowed us to produce the changes more rapidly. And as I mentioned, we have a lot of coarse grain services, which, if you're familiar with those, they were really great when you had high network latency, right? They helped keep the chattiness low. It was actually a best practice at the time to do it. But we found that there's downsides as we tried to live with these services over the years. One of them was, by their nature, they were pretty wide, right? They weren't the small, focused kind of service you see with microservices. And this expanse of the service means that we were mixing code that changed a lot, business rules that were kind of based on our current strategy in the market, with things that didn't change very often, like how we call a credit authorization vendor. Because these services change a lot, that means the clients have to change a lot. So this leads us into kind of a negative reinforcement loop of, we have services that have to change a lot, but because they're widely used, we have to do a lot of testing. So that means we try not to change them any more than we have to, which really just gets risky. And by the way, we don't have the extensive test suites that we get in our modern practices. So because it's risky, we stay up and deploy at 2 a.m. so that we have a few hours to work out any kinks before people show up for work in the morning. So if I was to try to summarize, the downsides of what we've been doing, it's difficult to change services that you have to change all the time. We also had some challenges with the technology platform we're using. Because it's a platform that is not in as wide use now as it was when we adopted it. We have difficulties hiring people. And it's also hasn't, it came about in an era that was before the CI/CD movement, and so the way it manages the code that you write also didn't lend itself to being able to use these techniques with it. And it also had operational challenges. We were challenged with trying to auto-scale it and do the CI/CD pipelines to deploy on it. So when we take all these things together, we think, well, we need to switch to microservices. But that's easier said than done, right? If you think about switching to microservices, I kind of put this as a semi-facetious list of all we have to do is go through all of our business processes and try to decompose them into small little units. And by the way, some of those things people figured out 15 years ago, so that should be pretty easy to get through it all, right? No. We actually started off down the path of trying to do this, and we got through a couple, and we realized that the overhead of having to reanalyze the business process and modularize it was going to put us on a timeline that it was going to be years before we fully got off the old platform. So we tried to look at a way of, could we switch it around a little bit and get some of the value earlier and really get off of some of the older platforms so we could focus more of our resources on where we want to be, which is, I thought I had this thing there, which was to use this microservices strategy and deploy it continuously on Cloud Foundry. So to talk a little more about the details of the environment, I'm going to hand things over to Lax. Thanks, Lax.
Thanks, Rob. Good afternoon, everyone. Thank you for joining us for this presentation. I see all empty seats are filled by Pokemon. Really, these are the only two themes, microservices and Pokemon. Every presentation I've been to, there was a discussion about microservice and Pokemon. But don't try catching them in Vegas. You know, Vegas rules apply. You won't be able to take them back. Anyway, I'm going to cover in next few slides about Dish middleware system, what we have today and what we're trying to achieve in next coming months and year. So as you can see, we have about 13.6 million customers, pay TV subscribers, and these services are really supporting all these customers with the either customer acquisition, the servicing, or really self-service tools and customer calling phones or calling the customer service representatives. So that's where our services comes into picture. We have about 100 plus SOAP services and 600 operations. And these are really written in various legacy technologies, which are not supported by CI/CD, and that's where we are planning to move them out of that technology stack. Point to be noted here, we have just about 5% to 10% Java code there, which means that you have to pretty much rewrite everything as you convert into Spring-related technologies in Java code. You can see some of the common business functions that we are implementing in our services. We are generating about 1 billion events today, be it a log event or any customer account specific event. So it's a very complex environment, a lot of servers deployed to support these services. The next is where are we today and what we are trying to do next. Obviously, we have front-end applications, multiple apps. They are coming to F5, connected to legacy SOAP services, and then connected to back-end resources. We are taking a multi-phased approach to convert these services onto Cloud Foundry. And stage one of that is really converting these SOAP services as is to Pivotal Cloud Foundry platform with a endpoint Spring Framework annotation and connected to same backend resources. No endpoint change, no logic change, no payload change. So it's seamless to apps. You are literally converting it as is. Apps doesn't even know their service is running now on Cloud Foundry instead of your legacy platform. Now, the advantage to that is our Java code is already converted as part of that. We have converted everything to Java code. Now, stage two of that is converting them into microservices, REST microservices, and which means you may have to ask applications to change their endpoint to payload, change their payloads, but we can parallelly host these services onto legacy and new platform, and then continuously move them as time permits. You can see some microservices looks like a pizza slice, and my very basic analogy to microservice or monolith is, I would try having a pizza without slice, just having a whole pizza versus slice. So microservice versus monolith. Then we are going to use a shared code library because you have a Java code converted there. You're going to use same Java code in your business logic or shared Java libraries in your REST as well as SOAP. So you're not rewriting everything. Talking a little bit more about how did we prepare for the migration. We took our service catalog, categorized them with what kind of design patterns we were using, the size of the services, big, small, kind of a t-shirt size, a number of moving parts with each service, what are the building blocks needed for each service to be delivered to the new platform, deciding the scope of work, and then assigning priorities, effort estimation for each service so that we can plan accordingly. Choosing the right technology to support the services roadmap. Apart from Pivotal Cloud Foundry and Spring Boot, Spring Technologies, we did evaluate multiple open source platforms as well as out-of-the-box ESBs, but in the end, we picked up this one. And literally, you really need to start small, build on the building blocks, build what's needed for the most complex service upfront as you deliver smaller services, and then go big. Obviously, spread the word across your company, all the teams you interact with, what exactly we're trying to do, educate them. And last but not the least, get a buy-in from the management. You're not going to go anywhere without that, that's for sure. So, next slide, key technologies that we are using on the new platform. Spring Boot, deployed on delivering standalone Tomcat applications. Spring Framework, Spring Cloud, and applications deployed on Cloud Foundry, Pivotal Cloud Foundry. We are using JUnit and Mockito for extensively unit testing our code base. And then Gradle, Jenkins, GitLab, and Artifactory for all the build pipelines and code repository. We are using Zipkin and Alk Stack for giving the visibility into services. And then Jamfire, RabbitMQ, and Kafka are serving us for cache. Multiple services require cache management, and then guaranteed delivery framework. So that's high-level technology stack. Where are we now with our conversion effort? We are not doing any new development, net new development on the legacy platform. Obviously, you still need to maintain your BAU stuff and fix bugs and all those stuff, but no net new development. We have converted 7 of our legacy services out of 100 odd. All the new services are being developed onto PCF. Second, it stays on the roadmap. 12 new services have been developed so far, net new. We are reusing our integration test suite developed for legacy platform to test our current new services on Cloud Foundry because, again, no change in interface, no payload change. You can use same test interface for testing the new services. Zero to minimal impact to our service consumers. And right now, each PCF app has 8 instances, 4 in prod because of active, 2 per data center, and then 2 in test, 1 for dev and devent each. That's all I have, and I'll hand it over to Chandra for the most interesting part of the presentation, the actual code that we have written.
Thank you, Lex. This is Chandra Nemalipuri. I'm working in a Dish Middleware applications team. So for converting the services, legacy services to the Java services, we are using Spring Boot and Pivotal Cloud Foundry are as the key technologies. So Spring Boot is around for some time now. So we started using Spring Boot 18 months back for one other key initiative along with the Pivotal Cloud Foundry. We are using the same technology stack to convert the legacy services to the new Java services or building brand new microservices. So the main benefits of Spring Boot is like it provides the common platform and libraries to build software. Say for example, like if multiple teams are working on a project, we certainly don't want each team to build a new version, a different version of the software. So Spring Boot provides a common platform and libraries. Apart from that, compared to the Spring framework, it greatly reduced the config and setup, and also there is no need of a container. So it comes along with 3 default containers. So by default, it spins off a Tomcat server. And apart from that, it also, like, using the profiles, we can segregate the environment variables like a development, test, in production. For each environment, we can provide the configuration parameters. So apart from that, we are using 12-factor guidelines. We are following the 12-factor guidelines, and also test-driven development. And also we are using existing test suites for the Cloud Foundry services. For the exposing the services for internal as well as external clients to make call, we are exposing the services as well as services for the REST as well as the SOAP. So we are using Spring frameworks, Spring WS, and Spring Web. So for the runtime environment, we are using Pivotal Cloud Foundry to attach all the backend resources of the application will be attached as the external resources using UPS, user provided services, or marketplace. For example, like MongoDB, Elasticsearch, and any other internal database configurations will go as a user provided service. And also we recently started using a Gemfire as a distributed caching solution. So we will be using for the application data caching. Once we check in the code to the GitLab, we have DevOps CI/CD pipelines will take care of the deployment, building the code as well as the deployment. So when we check into the GitLab, CI pipeline takes the code and runs the test cases, generates the test coverage reports, and creates the application artifact file in Artifactory. From there, CD pipeline takes the Artifactory and deploys into Cloud Foundry. And also it makes sure that all the deployed applications are working fine. It checks the application's health status as well as the binds the primary root to the deployed version. So we have altogether around 6 manual gates to make sure that code is flowing together along with all the other dependencies. So only restricted users, only specific users have the permissions to push the application into the next step. So we have development, integration, test, and production environments. After deploying the application, we have few mechanisms to monitor the logs, monitor the environment and application, as well as the analyzing the latency reports. So for the latency analysis, we are using Spring Cloud Sleuth as well as Zipkin. So these components will provide the distributed tracing solution. So in a monolith application, it is easy to identify the problems such as if messages are getting dropped, or if components are not tracking the traffic, or SLA is out of range. So these problems can be addressed in microservices using Spring Cloud Sleuth with Zipkin. So Spring Cloud Sleuth, it prints a timing data along with the context information. So that data will be used by the Zipkin to analyze the latency problems. So these component supports the different messaging channels, like if a message is coming through Kafka or Apache Kafka, Kafka or RabbitMQ or HTTP channels, or if we are making external call with a REST template. So those messages will be tracked using Spring Cloud Sleuth. So it prints the information in the log file. From that log file, the timing data will be pushed to the Zipkin server. So this implementation leverages Spring Cloud Sleuth and Open Zipkin components along with Cassandra and LogStash consumer. The other mechanism we have is elk stack. So Elasticsearch, LogStash, Kibana, and Kafka. So these components will provide the log metrics. So after printing the logs in Cloud Foundry, those logs will be pushed to the Kafka. From there, LogStash consumer pick those messages and then put it into the Elasticsearch. From there, we have Kibana to view the logs. So we have 12 factors. So how a dish is fulfilling those 12 factors. So this slide give you the information about 12 factors as well as the implementation at the dish. So we have 3 stakeholders: development team, operations, and PCF. These 3 together are fulfilling the 12-factor guidelines. So application code must be checked into the GitLab, and all the configurations will be segregated using the profiles, and all the external dependencies will be defined in the Gradle, and make sure that application is a stateless process. And operations teams takes care of like a CI/CD pipelines, and they make sure that the development and all the environments are same. So PCF takes care of few factors like as soon as we deploy the application, it generates the DNS name for the application. And also it uses the build pack to externalize the dependencies and dynamically scaling the application as well. So altogether we are fulfilling 11 factors. 12th factor is not applicable, which is admin process. So we don't keep any admin process in a middleware application. So I have a demo app called SpringOne demo app. So that is actually covering all the implementations. So I have a recorded video without audio, so I will talk as it moves on. So when we annotate application with a Spring Boot, so it actually configures the application, auto-configures the application. That means that whenever the application launches, it scans the class path and initializes all the beans. And I have imported the dependencies as well as defined the configuration properties. I disable the shutdown actuator endpoint, and disable the security, and the actuator endpoint has been mapped to manage endpoint. So when I started the application, it scans the class path of the jars and it defines all the beans. So here you can see all the actuator endpoints like health, environment, dump. So all these endpoints are predefined by the Spring Boot application. So whenever you put the Spring Boot application in the class path, it actually defines all those endpoints. After launching the application, you can now access those actuator endpoints for the ops info, like you can view the information about the application as well as the environment variables, dump, thread dump of the application, as well as the endpoints. What are the endpoints exposed by the applications? All the endpoints defined. So here, when I launched the application, I used a dev local profile. So which means that it picks up the application dev local file. So if I want to use the different environment profiles, so we'll have to define properties for each environment and put it in the config server. So we use a Spring Cloud config server to access the environment variables. So I have a config client in the class path in the Gradle file. And for all the other environments, manifest, dev, int, test, and prod. All these 4 files for the external environments, those files are not part of the project. So moving on to the how do we generate Java classes using the WSDL? So that is there are a number of ways. We are using JAXP binding compiler with WSDL for J. So that actually generates the classes in the build folder. So I have imported all the required dependencies into the class path. So genjaxp is a AND function that takes the visual file and generates the Java sources in the generated sources folder. So in the endpoint, how do I refer those Java classes? So in the endpoint, using the endpoint annotation, I have made this class as the endpoint. So this method, getTags code, has been exposed as the SOAP method using like a payload route. So that is a handler method. So whenever it receives a request with the matching namespace and the getTags code, so it will expose that as a SOAP method. And also similarly, I have a REST controller. So request mapping is the annotation I use for exposing the REST method. So when we start the server with the class path like Spring WS and Spring Web Components, so we can access those SOAP and the REST services. So I am using Swagger documentation as well, RESTful documentation called Swagger. So I have defined API operation for the Swagger setup. So imported all the Swagger dependencies, Swagger UI and the Swagger core, and defined the API info here, like license info, what are the controller methods I want to expose in Swagger page. So application port and the Swagger UI.html, so that will list out all the methods that has exposed by the API method. So moving on to the next one, which is Zipkin. So for the we have a common project. So, but for the demo purpose, I have placed all the code in the within the same project. So in the Zipkin, the export, like I have defined all the properties in the config file. So we can configure the things like how much data we need to capture for comparing the data. So for the Zipkin, I have one means 100%. 100% of the requests has been tracked by the Zipkin. So we can put a 0 to 1. 0.1 means 10% of the requests will be tracked. So I have a custom implementation. How do I track the Zipkin data? So here a sampler and a reporter. So that will print the messages in a specific format, dish Zipkin. So that is a format to print the span IDs, trace ID, span ID, and all the timing data will be printed. So when I call the actuator endpoint, it actually printed the span info. So here I'm making a actual call to that service to make sure that the span data is printing. So here, for that call, it printed as Spring Sleuth component printed this data. This data will be used by the Zipkin component to contextualize the request. So this particular data will be passed by the LogStash consumer and put it into the Zipkin server. So what is the delivery lifecycle of the cloud native application? So here I have all the config files checked into the GitLab config server. So all these 4 config files as well as the code will be placed in the GitLab. So from there, a CI pipeline will take the code and then create a artifact in the Artifactory. So it will generate the jar file as well as the places all the deployment manifest files into the Artifactory. So in the next page here, you can see jar file as well as the manifest dev in test and prod. So the CD pipeline will take these files and deploys the application into the Cloud Foundry, Pivotal Cloud Foundry. So here, after deploying the application, we can monitor the deployment status of the application as well as the logs and routing endpoints and other the attached resources. Here, dish properties is the only attached resource for the application. So after deploying the application, we have few mechanisms, as I said in the previous slides. So here I have the Zipkin component. So I picked the SpringOne demo app as the application, and the latest request took 392 milliseconds. So this is the the timing of each component. So we can track what is the response time of each service. Elk Stack, the other component we are using for monitoring the logs. So here for the one of the sample application, I have a dashboard. Similarly, we have Wiley. Wiley is one of the APM tool. So to monitor the performance of the application as well as the environment. So with that, I have completed the demo. So the source code for the applications is available in GitHub. So you can both a SpringOne demo app and the dependency app is a simulator written in Ruby. So whenever you make a call to this internally calls the dependency app to get the required response. So yeah, any questions for
one
us?
thing I would just add that everyone's story is different. It's just our way of how we implemented it, but take a look at what works for you, right? It's definitely start to feel like a race to go to microservices. Also, don't get carried away. It reminds me of kind of car advertisement, 0 to 60 in 5 seconds, 0 to 60 in 3 seconds kind of things. So it's not a race. You have to analyze, evaluate your things, what works for you, and take a right step. And like I said, we have implemented one approach, and it's kind of working for us. If you need any help, anything, feel free to contact us. We are here to provide any help we can. And thank you very much for attending. If you're a Dish customer here, thank you again. Thank you for you. If you're not a Dish customer, you should be trying Hopper 3. The best out there.